So one-to-one functions, we know what a function is, right? Like a function, if you have a relationship mathematically that's a function, it can only be a function, as a review, if every input has what?
One output.
Exactly one output, okay? If a given input has more than one output, it's not a function, okay? But now, functions can also be what we call one-to-one, right? So first, it has to be a function, okay? So just note, must be a function first. And by the way, what was that quick test you could use if you had a graph of a function to see what, or the graph of a relationship to see if it was a function? Anybody remember?
Vertical line test.
Vertical line test, right? You can only cross a graph once at any place you draw it, okay? So you have to first determine whether it's a function, right? So once it's a function, it may be what they call one-to-one, all right? So what does it say? Function is one-to-one if what this says is any given x value is different than some other given x value, and they also have different y values, okay? So it could be a little confusing. Every input has a different output, okay? So every unique, it has unique inputs x's, and each x has a different output, all right? So you might be thinking, it sounds a lot like function, right? But it's not exactly, right? So it's exactly one-to-one. Every one input has one output, and every one output has exactly one input that makes it, okay? So probably the best way to deconfuse you is to go through a couple of examples here, all right? So it says of the four tables below, one represents a relationship where y is one-to-one. Determine which. So first of all, we have to check and see, is it a function? And then we can see if it's one-to-one. So let's take a look at number one. First of all, is number one here a function? Does every input have exactly one output?
No.
No, look, an input of 4 has an output of 2 and an output of -2, and the same with 9, okay? So this is not even a function, not even a function. So we can't even, proceed from there to see if it's one-to-one. It's not even a function. Let's look at number two. First of all, is it a function? Does every input have exactly one output? Yeah, it's a function, right? So this is a function, but is it one-to-one?
No.
Are there any inputs? Are there any outputs?
-2 and 0
Right.
share the same output.
So it's almost like we're thinking of the inverse now, right? So here's a couple of outputs that happen twice from different inputs, okay? Everybody see that? Okay? So different inputs or different outputs come from the same, now I'm getting tongue-tied, okay? So the same output comes from different inputs. Let's put it that way. Same outputs come from different inputs. Okay? Let's go look at number 3. First of all, is number 3 a function?
Yes.
It is a function. Okay? Is it one-to-one?
Yes.
Okay? In other words, does every output here, y, come from a different and unique input? Does it?
Yes.
Okay. Now, if you go back and look at number 2, this output for y, this output of 1, comes from 2 separate inputs, right? And over here, every single one of these outputs comes from a different and unique. So this is 1 to 1, all right? Quick look at number 4. Determine whether it's 1 to 1. Is it even a function?
No.
Why not?
because because there's two inputs that have different outputs.
Yeah, that input of
Different
-2
input,
has two
different
different outputs, right? So this is not a function. So we can't even check for one-to-one. So it's starting to make sense maybe, okay? All right, so let's go down here. So you know how the test for if it's a function is a vertical line test? Once you have a function, what do you think you might be able to use to test whether it's one-to-one? If you use a vertical line test for function, what might you use? Horizontal, right?
Horizontal.
Yeah. So we'll probably use a horizontal, or we'll definitely use one, line test for one-to-one, okay? But first do the vertical line test, okay? So let's consider the frame. So part A, let's just do this step by step. So here's our 4 graphs. Part A, circle the 2 graphs above that are functions, okay? So let's do the vertical line test. How about number 1? Is that a function?
Yes.
Okay. How about number 2?
No.
That's not even a function, right? We're not even going to check for one-to-one. How about number 3?
No.
No. How about number 4?
Yeah.
Number 4 is a function, so we'll circle it, okay? Now over to part B of the 2 graphs you circled. Which one of these is one-to-one, right? In other words, every output comes from a separate and distinct input. What about graph 1? Remember that graph itself is the set of outputs, right?
Oh, just like always, you're right.
These are all the outputs. Is graph number 1 one-to-one?
No.
It is not. So like take a look at, let's take an X value here, right? This X value of, I don't know what it is, has that output, right? And there's another X value that has that very same output value. Wouldn't it be about here? Right? I'm getting a little sloppy here, right? So those 2 X values have different outputs. Okay, in other words, that output comes from 2 different inputs. So it's not one-to-one, right? In other words, let's try the horizontal line test. And it fails it, right? So let's go over to graph 4. Would this be one-to-one?
Yes.
Yep, every single output comes from a separate and distinct input. So number 4, we'll just note, is one-to-one. Okay? Number 1 has outputs that come from 2 different inputs. It has outputs from 2 different inputs. And that kind of makes sense, right? That graph number 1, what do you think that's the graph of? Would it be like that, right? And you'd have to solve that, right, by taking the square root, wouldn't you? What do you get when you get a square root? How many answers? Whenever you take, how many answers do you get when you take the square root of a number?
1.
No, not 1.
Oh, 2.
2 plus or minus, right? So that makes sense that you get a plus or minus answer every time you take a square root, right? So every input, almost every input has the same output, right? Or if I say that properly. Almost every output has the same, comes from 2 different inputs. That's what I want to say, right? Except for that one down at the very bottom, okay? So one-to-one. All right, let's go over to the next page. And I believe they're going to talk about the horizontal line test. We just talked about that, right? So to test whether it's a function, we use the vertical line test. We do that first, right? And then we can use this horizontal line test if it's a graph to see if it's one-to-one, right? So let's go down and do a couple of these. First of all, say which of the following represents one-to-one. Let's see if it's a function first, okay? Let's look at number one. Is it even a function?
No.
So not function. Moving on then. How about number two? Is it a function?
Yes.
It's a function, but is it one-to-one?
No.
Not one-to-one, right by the horizontal line test. Number three, is it a function?
Yes.
It's a function. Is it one-to-one?
Yes.
It is in fact one-to-one. How about number four? Is it a function?
Yes.
Is it one-to-one?
No.
Not one-to-one. Okay? So our answer is graph 3. Okay? Always check to see if it's a function first, and then if it is, then you can see if it's one-to-one. All right, let's go down to number 4. The distance of the number lies from the number 5 on a one-dimensional line is given by the function d of x for distance equals, you remember this is absolute value of x minus 5. Absolute value is always what? What kind of answer is absolute value? Always. If you take the absolute value of -2, what is that?
102.
What's the absolute value of +3?
3.
+3. The answer is, and usually when you're measuring distances, right, like especially in geometry, you're only interested in the positive distance from something, right? So that's one place where absolute value is handy, okay? So they want us to show by example that this function is not one-to-one. How might we do that? Are there some values that we might be able to pick? Like a couple of values we could plug in for x to show that we get the same output?
Negative, I know.
Hey, Jacob, you just drew on my screen. Try not to do that. Let's try.
Is it gone now?
Yeah, it is. Thank you. I'm not sure how that happens, but let's try like 7. Let's try d of 7 equals the absolute value of what? 7 minus 5, right?
Which is 2.
Which is the absolute value of 2, which is 2. Okay?
And that means the -7 has the same value. No.
I don't know about that.
No.
What other number is 2 away from 5? 7 is 2 away from 5, isn't it? What other number is 2 maybe to the other side of 5?
3.
Okay, let's try d of 3. So that would be 3, absolute value of 3 minus 5, which is the absolute value of what? -2, which equals 2. Hey, same output with 2 different inputs, right? Okay? So we have the same output for 2 different inputs. We have an output of 2, which comes from an input of 7, and from 3. Like if you were to look at this graphically, you guys remember absolute value is kind of, the graph of it's like a V. If I put X here and Y here, right? Looks like it gets shifted to the right by 5. So like kind of looks like this. Does this look familiar from algebra? Absolute value, right? So it passes the vertical line test, yeah. But what about the horizontal line test?
No.
No, right? So we've just shown, like, here's our 5, right? Here's our value of 3. Our input of 3 has an output, right? I guess that'd be 2, the way I drew it. And here's our input of 7. It also has an output of 2. See? So it cannot be 1-to-1, even though it is a function, right? So, man, any questions on 1-to-1? You have to prove first that it's a what?
Function as a
Function.
function,
If
and then
it's,
you have to prove that it's
and
one-to-one.
then you can show one. It's got to be a function first. Okay, let me